All right. Another advent of code. Bring the mic a bit closer. Another advent of code stream today. We've gotten through days 1 through 5, both stars. Yesterday was actually pretty easy. But the more I've thought about it, so yesterday it was basically a sorting based on some rules for the sort. And I think it was a bit of luck that this worked for my input, because I don't think this is guaranteed to work. I think you can set up a series of rules that wouldn't work with the sorting algorithm, because if we don't find an exact match for our two numbers, then it says that they're equal. And I think that would maybe confuse the sorting algorithm in some cases. But nevertheless, we got the 2 stars, and we're ready today to crack on with day number 6. And I'm still not sure what this image is supposed to be. Let's see. I just posted my thing, and oh, Pi Detective back here. Very nice. Yeah, I posted this in Discord, and someone just asked the question. I just had to answer it. Okay, day 6, Guard Gallivant. The historians use their fancy device, so I guess the sort of blink in and out of existence device. Device again, this time to whisk you all away to the North Pole prototype suit manufacturing lab. In the year 1518, so we're going back in time. Or I'm not sure when these are set. I think they're set in sort of today, but I'm not exactly sure. It turns out that having direct access to history is very convenient for a group of historians. It certainly would be. You still have to be careful of time paradoxes, and so it will be important to avoid anyone from 1518 while the historians search for the chief. Unfortunately, a single guard is patrolling this part of the lab. Maybe you can work out where the guard will go ahead of time so that the historians can search safely. You start by making a map, which is our puzzle input of the situation. For example, so here is a map. I guess the input map would be way bigger. So let me just write that out to an example file so we can work with that. And the map shows the current position of the guard with a sort of caret thing. To indicate the guard is currently facing up from the perspective of the map. Right, so he's facing this way. Any obstructions, crates, desks, alchemical reactors, etc., are shown as these pound characters. Lab guards in 1518 follow a very strict patrol protocol, which involves repeating following these steps. If there is something directly in front of you, turn right 90 degrees. Otherwise, take a step forward. I think guards in the 1580s were sort of proto-Roomba level of smart. Following the above protocol, the guard moves up several times until she reaches an obstacle. So she walks from here, up to there. Now she has this thing right in front of her. She reaches an obstacle. In this case, a pile of failed suit prototypes. Because there is now an obstacle in front of the guard, she turns right before continuing straight in her new facing direction. So she's walking right until she hits this thing, then she would turn right again, go all the way down there, over here, right, 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 and then out of the map, I guess. Yeah, reaching another obstacle is full of several very long polymers. She turns right again and continues downward. This process continues for a while, but the guard eventually leaves the mapped area after walking past a tank of universal solvent. By predicting the guard's route, you can determine which specific positions in the lab will be in the patrol path, including the guard's starting position. Right, including the guard's starting position. That's probably important. The positions visited by the guard before leaving the area are marked with an X. In this example, the guard will visit 41 distinct positions on your map. Predict the path of the guard. How many distinct positions will the guard visit before leaving the mapped area? And our puzzle input looks like this. It's quite a bit bigger. And I guess there's a guard in here somewhere. Does the guard always start facing up? It appears so. Okay, so guess basic simulation. Just sort of walk this guard along till she reaches the end, and then that's it. I guess, of course, like taking her along the path might be a bit computationally expensive. So you could probably do like find the one in this column with the lowest number and then just boom, straight there. But we'll try to do the simulation way. Yeah, 41 distinct positions. How big is this map? Like how many positions are there? It should be easy to figure out. Don't select anything. Save page. Day 6. Input.txt. Okay, so if we run, so in Linux you have the word count command, VC. You can use VC-C to count characters instead of words. And if we just give that to our input, we get an estimate for how big the our input is. It will of course be smaller because like there's a new line character here, which isn't a valid position. But yeah, 17,000. That's a bit more than I had hoped, because that means oh no, okay, we should be able to use a set. Okay. So I have an idea. Basically, we create a small set of visited positions. We say it's a set of uint16, which is the largest size you can make a set. Right, Pet Detective says today's problem sounds pretty cool. Yeah, there's always standard library int sets. We used the hash sets module yesterday, but we also have int sets. I'm not sure why that tries to put me in a super old version of Nim. Yeah, specialization of packed sets for integers. Packed sets can do any ordinal type as a sparse bit set. So basically the like built-in this kind of set is just a bit set. So this requires 65,000 bits to enumerate all the values. But these are sort of optimized for when you don't need all the values, which most often you don't. So we need to create our map, and I'm thinking I actually want to just store, I think I want to store my positions. So obstacles, just do them all as sets, and then do the guard position just as a tuple of xy integer, and we also need an enum here just to give our directions, north, east, south, and west. So north is the default facing up, and that just comes into play with our direction. So the current direction is north. I'm not sure if that's a general thing, but my input has it facing north. It would be trivial to make it not face north. So for a line in input dot, or let's start with example.txt, and then for item, I guess, or for tile, that's a good word, for tile and line. So that's all, each character in the line here. I also want to grab the index for both of these. So this calls the implicitly it calls the items iterator. Of course, in this case, we want to explicitly call the lines iterator. I'm not sure the lines iterator. Does this work? And I'll try to not horribly mess up my x and y like I did last time. That was embarrassing. Wrong number of variables. Yeah. Is there a? There's no. There's no like pair for lines. So typically, iterators in them, they have. So you have items and you have pairs. And pairs is what is automatically called in this case. So let's do this. Y0 inc y. Yeah. I guess there is. Yeah, we can't do pairs on that. Yeah, this is of course a way to implement it. But there isn't a. Oh, pairs and unpairs is already there. You want to import stereoutils. Right. Okay. So we do have a lines.pairs, I guess, in the stereoutils module. And then we can remove this and this. Undercloud field pairs. Didn't like that. Does it just have like a pair? No. Ah, split lines. Okay. Read file. It's not as pretty. I actually don't think I need pairs there. Why is this still cranky? Split lines should return a sequence. And sequence have the pairs iterator on them. Oh, okay. One of the strange places where NIM's universal call syntax fails. Patio Detective says that he thinks we have to use standard library enumerate module. Enumerate. That's not how you spell that. Syntactic sugar enumeration for any kind of a for loop statement. That's exactly what I was looking for. Enumerate. Oop. Then we can do this and lines and enumerate, I guess. Oh, that is such a new module that you have to import it like this. Do I have to call this with oh, I have to get rid of that. And maybe make this into a call? Or do I have to, oh, there we go. No? Iterable string. Okay. So we have to do it like this. Because it needs to take a for loop. Yeah. It's a limitation on for loop macros. So basically a macro that has one argument and it's the for loop statement. It will, instead of being fed just this, it will be fed sort of the entire loop, and you can do whatever you want with the loop in the macro, which is pretty cool. And yeah, new modules in an standard library, you have to use the std prefix for standard. And you can do, like, if you wanted more modules, you can do it like this. And all of the old modules can be imported with the std prefix, but doesn't have to. So I have used them for such a long time that I still tend to import without the std prefix, but we probably should be using std, all of us. Okay, so now we have the tile, and we have the x and y position for that tile. So we can do a case statement over tile, and if this is a dot, then just ignore it. If it's a pound character, then it's an obstacle. Then we obstacles dot include, and we have this set, the set of just one number. So we need to, so we could have used a hash set with a tuple like we did yesterday, but to do something a little bit different today, we're going to sort of cram them together. So here we do y times line.length plus x. So that will just make one number which sort of uniquely identifies a position. And we can actually do a little trick for that a bit later, which will be cool. And then, yeah, if we find this guard position, then we just set, or if we find the guard, we set the guard position to this. Otherwise, just quit with an error, because that means there's something in the input that we didn't expect. Oh, and this has to be turned into a UN16. There we go. That compiles fine. So now we can see that we have a guard position, and we have a set of obstacles. Nice. So what I was talking about, we can make a type, the cool little trick I was talking about. We can make a type called a position, which is a distinct UN16, or we can just make it a UN16. And we can say that these are at a position, and then we can make ourselves a procedure. Just call that pos xy, integers, and it returns a position, and right, it doesn't have access to line, so it can't do line length out of nowhere. We can move that in. We can move that into here. We can actually make this a template. There. Now we can say include position xy. So basically what this does, we have just created an alias for a position, which just makes the code a bit more sort of obvious. It's not just a UN16 anymore, it's a position. And the way you obtain a position is that you call this template with an X and a Y. And all it does is the same math that we had earlier. Yeah, that's one thing NIM needs to improve on. Errors are not always super helpful. They have gotten a lot better. They used to be way worse, but I totally agree that they could definitely be better. I think we're gonna move that out of there though, and you'll see why in a second. But I'm gonna say map width is map width is an integer, and then here I'm just gonna say map width is equal to line.length, and then I'll say map width in there, so that way we can use, after this loop is run, we know the width of our map, and that way we can use position without having to iterate over the file again to get the line length. Right, so now we have everything we need. So we have our guard, we have our obstacles, we have the size of our map, and then we can say while, well, we'd actually say while the guard position.x is in the range 0 to map width, and the guard position.y is in 0.map width, and I guess that would be, oops, like this. So as long as we're inside the map, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the position is 0 based. So it'd be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we need to be in the range from 0 to 9. Map width ended up as 10. So this makes sure that we're inside the map. We'll do a case over the current direction. And if the current direction is north, then guard position.y is minus equals 1. If it is south, y is plus equals 1. And then for east and west, let's do west and east, it's x minus 1 and x plus 1. So that takes care of moving the guard in all the directions. And now we need to check the break when the map is wider than tall. what about having map height? Oh, right. I didn't even think about that. I guess like this map is square. This map is 130 characters long. No, the file is 130 characters long, and the lines are 130 characters long. So the maps are square. But yeah, we should have probably done map height as well, and said that map height is equal to oh, actually, yeah, map height, just increase that for each round. If you run this, yeah, 1010, good. Oh, and yeah, since our loop is here, it just walked straight up out the map. Nice. And then the loop quit. So now we need to see that after we have moved the guard, is the thing right in front of the guard a box or not? So if, yeah, I guess we can do another one of these. Another case, if we're heading north, and if there's an obstacle, yeah, that contains if there's an obstacle at y-1, yeah, y-1, but it's the other way around. So if there's an obstacle in front of us, then current direction plus equals 1, I don't think. You think I forgot to? Oh, right. So Patio Detective said I forgot to change this, and I did. I mean, they're the same. But yeah, it should be like that. The current direction needs to go up, and I guess since we're in this loop, we can just say that it's going to be east. We can delete all of these. And just paste these in here. It's a bit repetitive. We could probably do this a nicer way. Oh, I forgot that. So if we're heading south, we are going to be heading west. If we are heading west, we're going to be heading north. And if we're heading east, we are going to be heading south. And for west, we should check at -1. This should check at +1. And let's remove these. There. Okay, and then of course we need to add the location that we have that we're on. .x. Actually, we're gonna do that in the beginning, and you'll see why in a second. So our goal is to count all the tiles that we've visited. So we include oh, and this is of course needs to be a position, not a tuple, because we are using these int sets. So yeah, we include the position that we're at. So we start at this position, and the starting position should be included. So we start with that. And of course, this check doesn't run until after we're done. So this would walk us off the map. This would try to update the direction, but that doesn't matter. Like, it shouldn't do anything because we haven't created a map. So we're not running indexes like falling off the map. We're just checking a set here. These all, of course, also need to be positions. We're just checking if an int is in a set. So it doesn't care if these sort of go out of range. The only thing, I guess, if you go negative and we end up with a negative number, but that, since these are unsigned integers, it should just wrap around, but we'll see. So yeah, then we can echo out the visited cardinality. Oh, not all cases are covered. That is because it doesn't like putting if statements directly inside of an off block. There we go. Python Detective, I have nph formatter automatically enabled on save for nym files, so I never write inline nested statements. Yeah, I had a look at the set. So nph, as it says, it's an opinionated formatter for nym, and it's basically it formats nym code. I'm not a huge fan of the format. Like, it is opinionated. There's no configuration. I think that's a good thing. I'm not a huge fan of the format it spits out. Like, it has improved some things, like these lone commas and some other like awkward things. But I'm not a huge fan. Like, as you might have noticed, like, I write wide statements. I like inline ternaries. So yeah, call me crazy, but I don't like the nph formatter. I mean, it's a nice project. It's a good idea. I just don't care for the style. Yeah. You don't care that much about the style, but more about lines not being too long. I can see that. And it would for sure work for that. You can't see it because my terminal when I'm doing these streams is so small. Oh, actually this theme, right, I disabled it for when I was doing the presentation, because some find them really confusing. These would actually be too long. But I have a red line running down at 80 and another at, I think it's 120 characters, which is the longest it gets. If you go on GitHub and look at a file there, that's the width of those. So I tried to sort of break on those manually, but I just like it being manual. Yeah, 41 was what this spat out. Let's see, advent of code. 41 was the distinct positions. So now if we run this on the input, which is of course a much larger map, it will walk a much longer path. But that was actually a bit surprised by how fast that was. I thought this would take at least a little bit longer. I mean, nym is pretty fast. This is also in debug mode. If you compile in release, yeah, no time at all. But that doesn't matter if it's not the right answer. But of course, it's the right answer. 1 gold star closer to finding the chief historian. So yeah, that was pretty easy. I guess maybe like if you did the whole string thing and walked around, it could be a bit slower. This is basically just make an integer out of this, then shift a bit those many positions over, or that, and that with whatever's in that position. So this is just basically bit operations. So it should be super fast. But yeah, branching logic. Thought it would be slower. Maybe I was lucky and we exited the map quickly. Right. Part 2. While the historians begin working around the guard's patrol route, you borrow their fancy device and step outside the lab. From the safety of a supply closet, you time travel through the last few months. Wait, what? Yeah, so they're working on the guard's patrol route. You borrow their fancy device, step outside the lab. From the safety of a supply closet, you time travel through the last few months and record. Why is the record a link? Oh, right. We have apparently been recording guard schedules before. Kinda shifty. Record the nightly status of the lab's guard posts on the wall of the closet. Returning after what seems only like a few seconds to the historians, they explain that the guard's patrol area is simply too large for them to safely search the lab without getting caught. Fortunately, they are pretty sure that adding a single new obstruction won't cause a time paradox. They're pretty sure. They'd like to place a new obstruction in such a way that the guard will get stuck in a loop. Oh, nice. This is why I drag my mouse over all the text, because sometimes the creator hides these highlights. The vulnerability was later fixed by having the guard always turn left instead. Yeah, that's a permanent fix. That's the kind of fix people do and then forget about, and it bites them in the ass later. Making the rest of the lab safe to search. To have the lowest chance of creating a time paradox, the historians would like to know all of the possible positions for such an obstruction. The new obstruction can't be placed at the guard's starting position, and the guard is there right now and would notice. I guess he won't notice if you put it right in front of him. In the above example, there are only 6 different positions where a new obstruction would cause the guard to get stuck in a loop. The diagrams of these 6 situations use an O to mark the new obstruction, a pipe to show the position where the guard moves up down, and a dash to show a position where the guard moves left right, and a plus to show a position where the guard moves both up down and left right. Option 1, put a printing press next to the guard's starting position. So right there, because then it would move up, right, down. Instead of moving all the way over to this one, he would turn. Option 2, put a stack of failed suit prototypes in the bottom right quadrant of the mapped area. So you'd go up, right, down, left, up, right, down, and then you get stuck in this loop. Option 3, put a crate of chimney squeeze prototype fabric next to the standing desk in the bottom right quadrant. A crate of chimney squeeze, right? Right there. He will get stuck in this loop. Option 4, put an alchemical retro-encabulator near the bottom left corner. He would get stuck in this loop. No, this loop. Option 5, put the alchemical retroencabulator. This has thrown this in for people like me who tried to stream this a bit to the right instead. And then he gets stuck in. Ooh, then he gets stuck in a long loop. Then he gets stuck in this sort of entire thing. Okay. Option 6, put a tank of Sovereign glue right next to the tank of universal solvent. Right where he is exiting. If you remember when we went through the one above, he exits through here. If we put a thing there, he will end up in a loop. It doesn't really matter what you choose to set it as an obstacle, so long as you and the historians can put it into position without the guard noticing. The important thing is having enough options that you can find one that minimizes time paradoxes. And in this example, there are 6 different positions you could choose. You need to get the guard stuck in a loop by adding a single new obstruction. How many different positions would you could you choose for this obstruction? Yeah, Python Detective says, I can totally see the C version of this solution being completely unreadable. Yeah, that's a nice thing with Nim, is that you can do things like have this as a position and sets built in that just do all of the like bit shifting stuff automatically. Which in my mind makes this super readable. Like, this is a set of positions. It's actually a bit set of UN16. But no one needs to know that. This logic, we only do it once here, and then it's just sort of used everywhere, which is fine. And like contains is a lot more sort of verbose. It tells us what we're doing instead of shifting and anding and oring. I do notice that I tend to sort of go off camera sometimes. I tried to turn the camera today, but apparently I didn't turn it enough. Yeah, okay. So we need to have a way. Oh, not move. Copy. Ooh, no. God damn it. I really should turn off that autocorrect thing. It's super annoying. Right. Part 2. In day 6, please. There we go. So we need a way to figure out if we're in the loop. Like right now, if we placed a loop somewhere, we would just get stuck. Like it would just run forever and ever and ever in this loop, and we would get stuck, which is not what we want. We want to be able to determine if we are in a loop or not. And we can't just check like if we encounter a position we've been in before, because like we keep walking into positions where we've been. We need to see if we if we are in a position that we've been before and we're facing the same direction as we were the last time we were there. Which of course makes this a little bit harder. Because we need to store more information. And we are y times the problem we're facing here is that if we are at the highest position in our map, and we also want to encode the 4 positions, then we are over the size limit of a UN16. So we don't have enough room in our set to encode all this information. Patio Detective, I was thinking about having a proc guard position in int, where in is how far in the future to look at. And it will return position direction, as you said. How far in the future? So you would want to simulate. But how would you know? How would that help you? I think what we're gonna do, we're gonna use insets. And let's do it the proper way. Like this. Insets. Sets. Insets. Yeah. Insets. We have init, inset. These are just a packed set. So we can look at the packed set documentation. And it implements all the things for a set, which is good. So now we can just say that a position is a, let's just make it an int. And then this is an inset. And this is an inset. Right, that should actually be, oh, these don't have, well, an inset is literally just a packed set of int. It doesn't override anything, so it shouldn't do anything particular. So we'll just use packed sets. And then we can do packed sets. There we go. And then we have, what's a good word for position and direction at the same time? I can't think of a word for that. Yeah. But detective, to identify when he gets stuck, like wrapping the while loop you have in a proc. Yeah, but how would you know how far to go, like how far into the future to look? Vector. Oh, right, yeah, I guess vector. Vector is a decent word, I guess. So let's do vec, which is also a, which is a position and a direction. Returns the vector. And this should be a vector. And then I must time, like I can't just time this by the direction. I must time it, I must time the direction by the complete size of the map. So direction as an int, time that by map width times map height, and add that to this. Yeah, declared not used. So before we start walking, we have our path, which is a packed set not of position but of vector. And then in each one of these, we include in the path the vector of guard position x, guard position y, and the current direction. Before we do that, if the path contains, we just make a current vector here. Let's see, current vector goes there. Current vector. If the path contains the current vector, we are in a loop. So we need to track how many loops we have. So increase the number of loops and break out of this. And then I basically want to go through all of the positions. So for y in 0 dot dot map height, this isn't the most efficient. There are some optimizations for picking where to put the positions, but I'm hoping that this will be fast enough. Obstacles include the position of x and y. If not, or if obstacles, if it already contains the the position of the new obstacle, then we will just continue, because we don't want to add an obstacle sort of on top of another obstacle, because that wouldn't change anything, and it would mess up this part. So after our loop, we want to what's the opposite of include? It's not like de-include. Exclude. Yeah, exclude. Nice. So we'll loop through every position on the map. If there is already an obstacle there, we just carry on. If there's not an obstacle there, then we add the obstacle there. We run through. If this path contains, so we store our path as all of our vector positions. If the path contains the current position, that means we have looped. Increase the loop counter, break out of this while loop, so test the next one. And every time we finish the loop, remove the obstacle again. So it's important that we don't then remove an obstacle that was supposed to be there. And then we should be able to just echo out the amount of loops. And hopefully this will be fast enough. Like, Nim is a pretty fast language. So, and our solution, like the inner loop of this, was pretty fast. So I'm hoping that this will be pretty fast as well. I mean, it was fast. I'll give it that. It was completely incorrect, which is not great. Right, so our path is empty. Let's just first, before I get too into the weeds of this debugging, let's just do this, do that, remove this bit and echo out visited.cardinality. Invalid control for remove that as well. Oh, and this bit. There we go. Just run this. Yeah. Okay. So the refactor to inset is not what messed this up. I just wanted to be sure. Pet Detective asks, is there any benefit using sets instead of tuple xy dir? So you mean tuple xy dir in a sequence or in a hash set? The benefit of using sets is that they have fast lookup. Yeah, so in a sequence, if our path got really long and we wanted to check is there something in that path, we will have to loop through that path every time we want to add a new thing to see if it's already in there somewhere. In a bit set, we just store, like it's a data structure that has faster lookup, but we can't store sort of information in there. We can just store if it's there or not. So it should be much faster, which is the benefit there. Include that position. Oh, right, we don't reset the guard position. So the guard will just walk off the map, and then for the next loop, he is still off the map. Which is why this didn't work. So, initial guard position. Initial guard position. And then for each round in here, we say that guard, the variable guard position is equal to the initial guard position. So that way the guard position resets for every time through. This should, oh, I'm still echoing out visited. I should be echoing out loops. 90. The answer we're expecting is 6. Wasn't it? Yeah, 6 different positions where new obstruction would cause the guard to get stuck in a loop. But our algorithm counts 90 positions, which is more. So we only add one obstacle, and after each loop we take it out. So that should be fine. We'll loop through this if the path contains the current vector. Then we increase the count of loops, and then we break. That breaks out of this, removing the obstacle, going on to the next position. Well, that's a bit annoying. This takes an X and a Y and a direction. Uses map width and map height. So for north, these would be equal to a position. And we find 90 loops. I was like, I can echo out the loops if you find a loop. but I kind of don't want to echo out 90 different loops. So this is one example of a loop. Of course, kind of hard to decode. Or at least kind of annoying to decode. So this should be the start position, and he's heading north. Wait, he's heading north, so these should decrease. What? Echo out the position of guard pos.x, guard pos.y. Let's see what this gives us. Starts at 64, yeah, moving upwards until he starts moving right, so that only goes up by 1 until he hits the obstacle. Now he's moving downwards, which, yeah, increases by 10 each step. That seems to work, but this, oh, this is a set, so it's unordered, of course. Damn it. Wait. Let me just for debugging, let's do this. Don't echo out the path, echo out the path sequence. And add the current vector. Actually, don't add the current vector because that's annoying. Add the x, y, and the current direction instead. Oh, wait. We don't reset the current direction. Current direction, set that back to north. That is probably why. But let's do this just for fun. X, y, current direction. This should be a tuple of x, y, and x, y are integers. There is a direction. Right. That did not work. But that's because I used x and y and not the guard position. So we tried to add an obstacle at 0, 0, and that for some reason made him walk in a loop. That doesn't make any sense. So he hits 7, 9 going south. Where would 7, 9 be? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so he comes to the end. And he goes off the map. Oh, wait. Well, I'm an idiot. These, of course, also need to be in here. If he had ever walked that path before, he would have failed. Okay, I think that was probably it. Combination of stupid errors. Let's see if this works. Should print 6 at the end. Yeah. Very nice. That's the thing with doing these advent of code the way you do, like sort of part 1 and then part 2. is that it's really fascinating because basically what you end up with is technical debt. So if you're not familiar with the concept, technical debt is just as you build your code base, as you work on a project, small things, sort of, which you maybe thought was a good idea or which was fast enough or which I'm going to go back and clean this up later. All of those things that aren't sort of perfect and don't perfectly line up with what you're making today is called technical debt. And you sort of see like that's why small projects can come in and just be like way better than what has been there since forever. Is because they could start fresh, no technical debt. You can move fast, you can get stuff done. But as the company goes along, as the project goes along, you accrue more and more technical debt. And if you don't spend time removing your technical debt or paying back, I guess, your technical debt, then you end up suffering. So basically, you get into technical debt because you don't want to pay the price of a refactor. So you get some debt, technical debt, for not doing that. And then at some point, you spend all your dev time sort of paying back technical debt, and you don't have enough time to pay off your loans, so to speak. Which is a really good metaphor. And this part 1, part 2 of Advent of Code should sort of just really highlights that you get technical debt. Because what happened here was that I had my guard position, current direction as like global variables, which isn't very nice. And then I added this thing to the end, and I didn't consider like resetting them an issue. Yeah. But that seems to have been the issue, that I didn't reset the guard position and the path and the current direction. So it built up stuff that shouldn't be in the current run. Time to write a proc pretty map print to print that's the input. Yeah, that would be good for debugging. It's always fascinating when you have people who have worked on the same code base for a long time, and they look at something. Oh, this is taking. So now it's getting slow. This is what I was thinking would maybe happen, that it would be too slow for part 2. Of course, with the release switch, it skips some bounce checking, and it gets way faster. I'm actually not sure if release skips bounce checks anymore. I don't actually remember so before we had the release switch, the old release switch is now the danger switch. So actually let's compile this with danger, and then run hyperfine on part 2 to check how fast it is. And then run this a couple of times. Seems to take 3.2 seconds ish. 3.25. Yeah, as I was saying, it's really interesting seeing how people who have worked on a code base for a long time can just look at some like crazy output, like look at numbers like this, like, yeah, he's moving, like right now he's moving to the left because they get smaller by 1 each time, and here he changed directions, now he's moving up. Just like looking at what appears to be complete nonsense and know what it means. And again, part of technical debt. If you write nice functions, nice sort of ways for newcomers to be able to see what the hell is actually going on in your code, that will make it easier for other people to contribute. You have to have an amazing focus and imagination. Me? Why do you say that? I mean, my focus can be all over the place. For these things, it's kind of easy. Like, I can't pull up a YouTube video while I'm streaming. To debug mentally. Oh, right. Yeah. Yeah. I surprise myself sometimes when I'm just looking at a log flying past and I was like, yeah, I know what the problem is. To non-technical people, that must look like wizardry. Right. Yeah. So, danger, slightly faster than release. And I'm not sure I even want to try to run this without either. I think I'm just going to do with time, because Hyperfine is going to do multiple runs, and that already took a while. Let's submit. Oh, that's not the right answer. Oh, wow. I spoke too soon. Your answer is too high. Well. So it is right for, like, it works on this input, but it does not work on the actual input. Interesting. Which is kind of strange. Let's see. Yeah, so that took like order of magnitude more than a release mode run. So when we find a position that we've been in, that is definitely a loop, because the rules are the rules for moving are what you call that, deterministic is the word I'm looking for. They're always the same. Like, if I come here, I will always go right. So if I'm in the same position, moving the same direction, I'm definitely in a loop. But I think I realized what the issue is. Because we can't put it at the guard's position, because he'd notice. And I didn't take account of that in my code, which could have led to a weird case. So, or guard pause. Oh, right. So I should reset the state before I do this. So if guard pause is equal to X, and guard pause of Y is equal to Y. So if there's already an obstacle there, skip it. It can't create a loop, and our removal would break the set of obstacles. Or if the guard position is the position where we want to place one, then skip it as well. And hopefully, what the hell? These inline messages. So confusing. Yeah, this makes perfect sense. Oh, right. So the OR operator in them takes precedent, like the bitwise OR takes precedent over Boolean OR. So what happened here was that it tried to OR pos xy with this boolean, and it didn't like that. And this works. So my last number was 1773, and it said that was too high. So if we run this in release mode, if we get a number that's smaller than 1773, we got the same number. So it's still too high. So that was not it. Interesting. Okay. Obstacles. And then the guard moving, that should be good. If the path contains the current vector, increase the loop. That only happens once. Path include current vector. And we can never place one outside of the map, so that's fine. Now that we have packed sets instead of the int sets with unsigned integers, it won't wrap anymore around the map. It will go into negative numbers. But that's actually better for our use case. Or is it? Wait. If we end up in a negative position, but that shouldn't happen in here. So we start. We start by including our position in the visited. We don't need to do that anymore because we don't need to track places we've visited. The current vector is the x, y, and the current direction. If the path contains this current vector, then we increase the loop and break. Otherwise, we include it, and then we start walking through our simulation. And we do that as long as we are inside of the map. I'm not sure how this can end up counting too many loops. Yeah, this one has me a bit stumped, to be honest. We reset this before we check the position. It might help to break the code into smaller procedures so it's easier to reason about and debug. Maybe, yeah. That could help. But I think I have a logic issue. So we always have to be within the map for this to run. We had our starting position. Yeah, we add our starting position. Then we'll loop through. And if we ever come back on a path, it's annoying that the example works because like reading a whole loop for the big map would be really annoying. There's nothing else that we have forgot to reset. Hmm. Hmm. I guess our issue could be in my logic to vectorize. Yeah, I thought about that. Like we could try breaking something in the example. But then like the benefit of the example is that we know, like we already have the answer. So if we add an error into the example, then that would mean that we need to, yeah, if we add an error into the example, then we need to retrace manually to check if it's correct. It would be easier, of course, but so direction as an integer would be 0, 1, 2, 3. And we time that with map width times map height. So 130 by 130. Let's go. Oh, you can't see that probably. So 130, 130. So for north facing, this would just be 0. And then let's say we're at the like largest y. Oh, that would be 130 by 130. So being in the top left corner facing east. No, being in the top left corner facing south, which shouldn't be possible, would be the same as being in the bottom left corner facing up. No, facing east. So there are valid positions. I'm not sure if this will change anything, but nah. This is really annoying. I really thought that was like we had a solve there. And we didn't. And now, yeah, we can try to crop down the example. I'm just not sure like how. We've already been going for an hour. And it's getting kind of late here. So I think I might just call it a day. Which is of course not where I wanted to end things for today. I wanted to solve, but we loop through all the positions in the map. Add an obstacle. Walk the guard. Calculate the vector from the guard's position. If the path contains the vector, then we have a loop. I just don't see why this wouldn't work. Yeah, that's in the right place. is really annoying. Yeah, that is position. I'm not like mixing my vectors and my positions. Oh yeah. I'm still going to upload this this solution, and I'll probably get back to it at some point. Like maybe I'll have an idea at the moment I log off, like I usually do. So we'll definitely come back to this, and I'll post it on my GitHub. Um, hmm. I just don't see why this wouldn't work. Unless of course I'm missing something in the question. While the students begin working around the guard's patrol route, yada yada yada. I go back in time and do some recording. They want to add a single new obstruction. I'd like to place the new obstruction in such a way that the guard will get stuck in a loop. To have the lowest chance of creating a time paradox, the historians would like to know all of the possible positions. It can't be placed on the guard's starting position. The guard is there right now, and we notice. So we've checked for that. There are only 6 different positions where new obstruction would cause the guard to get stuck in a loop. Yeah. It doesn't really matter what you choose to use as an obstacle, as long as you and the historians can put it into position without the guard noticing. Have enough options. Yeah. Just for my sanity, let's just echo out obstacle.cardinality, and then the same cardinality in here. I just want to check that I only ever add one. 827. The last one. Seems like it's just like the last one. It takes a while. Or are these... No, these are sort of stuck. It's now just evaluating one really long one. Oh no, wait. It was just my terminal that stopped scrolling. 826, and then all these others are 827. So I only ever add one obstacle. Has it not completed? Oh yeah, it has. Just for some reason. Okay, so we only ever had one. We never added to another obstacle. We shouldn't be adding it to the guard's position. sure that this should be sufficient as a position. I guess it might be that I messed up this current vector thing. Let's try. That module is actually just called sets, confusingly. Let's try to define this as a hash set of vector and then store the actual information in our vector. Use hashes instead. This might just bring everything to a crawl. Kind of hard to know. X, Y, there. Yeah. I'm not sure what that is complaining about. Oops. Yeah, 1773. Still the same thing. Maybe you can't add it right next to the guard either because he'd also noticed. Yeah, but it doesn't say that. That's not part of the thing. I'm just echoing out like how long was the path? How long is the path that led to a loop? Just to see if I had any like wild outliers. Wait. Oh, yeah, okay. I thought I saw 1772 there for a second. We don't appear to have like any crazy outliers. I mean, these are short, but it's not impossible. There are some short ones as well. They do cluster, which makes sense. Damn, there's a lot of pass. Well, I guess there's 1,773, or not actually, but let me just in case I copied something wrong. No, answer is too high. Oh. Right. It has brute force protection. Yeah, no, I don't know. I'm out of ideas. This was really annoying. Like, not because it's hard, just because I don't know what I'm doing wrong. I don't know if I've like misunderstood something or if it's just, yeah. Yeah, I don't think I'm getting anywhere. Yeah, we have too many loops. You find too many loops. I guess we could try like mapping them all out, showing them. In 54, you just walk without checking for obstacles. HQM42 said. In 54, well, yeah, because I check for obstacles. Oh, if we add an obstacle right in front of the guard, he's gonna just move into the obstacle. So he's just facing through the obstacle the first time. Good, keenly spotted. I sort of thought of that, but in this input, it doesn't happen. So I didn't think, like, I just forgot about that. But yeah, of course, if we add it right in front of the guard, then right. So if y is equal to the guard position y minus 1, so if we add and x is equal to guard position dot x. So if we add the obstacle right in front of the guard, then just start the guard out with a current direction of east. Because we create the obstacle right in front of the guard, so just start him moving that way. And that should give us a different answer. Hopefully. No. Still 1773. So it wasn't that. Because in like, yes, I move, but then I check if my next move is valid. So since I check that my next move is valid, I know that I can do this move in the next iteration of the loop. So it's only in the case where we add one right in front of the guard where this would be an issue. So in this case, he would just get into the loop and then loop through. Yeah. There's that feeling of not wanting to give up because you think you're about to find a solution, but I think I prefer to try a different approach, like reorganizing the code to rest today and try again. Yeah, I think I'm going to do so as well. I don't think we're getting anywhere. Bit annoying to, well, not fail. We're having fun. It's part of the experience. But a bit annoying that we weren't able to find the right solution. Day 6. So yeah, bit annoying. Well, I'll do that afterwards. I just want to try. Are we off by 1? No. Okay. Fine. Have a look here. This. I have no idea what this is. Is this a waterfall? Like a body of water up here, sort of running off a waterfall. This is still Rudolph. Not sure if this is another leg. No. Not quite sure what this is. And why he suddenly turns green halfway through. Not quite sure what's going on with the image this year. But yeah, I'll get this uploaded, and I'll call it the day. Just quickly check over on YouTube. Oh, sorry, Robert. So I had a YouTube comment in 54. You just walk without checking for obstacles. I guess that's the same person that made it over to Twitch in the end. But yeah, that was sadly not the thing that solved it for us. I really hoped it would be, but alas. Oh well. Yeah, as I said yesterday, I might not be able to do it, like to do one tomorrow because I'm kind of busy tomorrow. But hopefully I'll be back soonish to do more days. As I said earlier, I'm not traveling for Christmas this year, so I should be able to continue a bit further. But these, as they go on, take more and more time, and Christmas is a busy time of year, so I'm not promising anything. But yeah, hope you enjoyed. Hope you're enjoying your Advent, and hope you're enjoying Advent of Code. And I hope you're trying. I hope you're doing it in Nim, because it's a cool language. Okay, that's it for me today.